Welcome to the Throttle Up podcast, a behind-the-scenes look at what it takes to build and launch a new class of rocket propulsion. Hosted by Sascha Deri, founder and CEO of bluShift Aerospace, and storyteller and entrepreneur Justin Starbird. This podcast follows the real work behind the mission. From early design and propulsion development to testing, capital, partnerships, and the path to launch, each episode brings you inside the process as it unfolds. This is your front row seat to watching bluShift Aerospace take off.
Welcome back to the Throttle Up podcast, where we take you inside bluShift Aerospace as we design, test, and scale our new approach to rocket propulsion, sharing real work behind getting from concept to launch. And Sascha, we just wrapped up episode 1, and today we get to welcome David Hayrikyan, the CTO of bluShift, to actually talk about, hey, man, you're out there doing the work today. We see you in the field.
Yeah, good to see everybody, and I'm excited to be able to talk about what we're doing here.
Sascha, when you met David, how did you know that he was the right guy for, leading bluShift, into the next, sphere?
Yeah, David's been with me since almost the very beginning. So way back in the beginning, we started a meetup group called Spaceflight Innovators way back when. And he was one of about maybe 20 people that came to this meeting talking about rocket propulsion. I had some ideas and concepts of what I wanted to do and where I wanted to go. And I knew I wanted to get similar-minded people on it. But what it came down to is, a couple of things with David. One is sort of that sort of ingenuity, the practicalness, the background from this mechanical engineering, machining. But I think in the end, David, one of the best things about you is your ultimate grit. By the way, you should do an episode on David and some of his background because it's amazing. But just the persistence. David would be literally working in our little version of a skunkworks room inside my old company, machining away parts and components for our rocket engine. And it would be 1 o'clock, 1:30, 2 o'clock, and he's still going. And he would do that every week as a second job. And as a fellow entrepreneur, he, unlike most people I've ever encountered, knows what it takes to push forward when it's the hardest. And that's a special person. So I feel very lucky to have David as my partner in this business. And he's been exceptional. He's gone from being one of the engineering team members to leading the engineering team. It's been amazing.
David, those are some tall boots to fill.
Yeah, they are. Also very flattering words from Sascha. It always makes me blush. But I think part of what happened those early days was the excitement of being able to use my skills on a project that I was passionate about from the get-go. I think everyone becomes an engineer to be able to work on cool things. Very few people become an engineer, at least the ones that do it out of passion, right? The ones that do it out of passion don't become an engineer to work on kids' toys or to work on dental product, even though those things all require engineering. And not shaming anyone that works in those fields in straight up manufacturing or in product development for something that's maybe less glorious. But for me and for a lot of the engineers I know, the appeal of engineering is fast things, loud things, impressive things, mechanically complicated, elegant things. And rockets sort of tick all those boxes,
Yeah.
So it was easy to work until 2 a.m. in that little skunkworks room, machining parts, because I was applying my skill set to something that I was really excited about, and that continues to be the case.
Yeah. It'll be come one of the garages that they show, in 30 years and say, look at where we started, right?
Yeah. We've got those unflattering pictures lined up.
Yeah.
Please,
All right,
know we actually upgraded to a garage at one point in time. So
that's true.
they had a non-functional bathroom, so there was not a bathroom.
Yeah.
Mother Nature was your bathroom.
Yeah.
That one point in time, that as we scaled up, that was our upgrade. So yeah.
Man. All right. So, David, at a high level, what have you actually built? And, really, how should people think about it in the context of today's launch systems?
Yeah, at a high level, what we've built is a hybrid rocket engine and a test site to support it that is able to deliver the performance needed for a lot of hypersonic and suborbital launch mission profiles. Originally designed around an orbital launch profile, which I think it would still have been capable of if we decided to go that route. But we designed a exceedingly simple yet capable and affordable engine to satisfy the needs of so many existing launch customers that aren't being met. And I think we've done it. I think we've done it in a tremendously innovative way. I think the engineers that work on this project, some of them are, uh, they are, despite me being the CTO, I'd say people on this team are my mentors. Technically speaking, they're brilliant people on this team, and practically speaking, they're very capable people on this team. And we've done something that I think would normally have taken 10 times more money to get to the point that we're at. And I'm very proud of that. And I think we're about to deliver a rocket that really that will embody our engineering approach for our customers, and they'll get to experience that affordability and that practicality and that simplicity. Never tried to make the Ferrari of rockets. We weren't going for that, and we're trying to make the perfect rocket for the job. And I think we're on our way to doing that.
Yeah. Yeah, Sasha and I talked about a little of that in episode one about, making sure that you're building what for the needs are, not necessarily to your point, to the highest end. But why go down that path? And why, why not go for the tallest, the fastest, the most elegant, or, the most sexy out there? Why just, I don't say to put it down, but why not, go to that end versus where you found seemingly more of a niche or a problem solve?
Yeah, I think I think the first answer to that comes from what Sasha's asked us to do, and that's to develop a hybrid rocket engine. And the Marvel rocket engine that we're making uses a solid fuel and a liquid oxidizer. Um, the highest performing engines in terms of ISP, in terms of the performance metrics that are typically applied for rockets, they're liquid fuel and liquid oxidizer typically, and they're using turbo pumps that add a lot of performance, and they're using cryogenic, very very cold fluids that take a lot of technology and hardware and energy to make possible. And they work really well. They're great for the job. They're great for orbital rockets. They're great for very large payload. And it's the things that we see taking people to the moon. It's the things that we see carrying payloads, Starlinks up into space, so that they're effective. However, in the small launch world, in the world of carrying CubeSats, in the world of carrying microsatellites up into either suborbital or orbital trajectories, you don't need all that performance. When Sascha said, I've got an idea and I've got a hybrid fuel to carry that idea, that sort of starts the framework. We know that we're not building the highest performance system. We know that we're building a vehicle around the capabilities of the engine. And that is simple. The single solid fuel and single liquid oxidizer, that simplifies the plumbing systems and all the control systems. So right off the bat, we're working on something that's not as complex, and that sort of becomes the mindset. Like, keep it simple, keep it simple. Don't overcomplicate it, because the benefit here is the simplicity. It has the performance that you need, not anymore. And that's perfect. We can meet this particular market demand at a lower cost than a liquid engine would do it.
Yeah.
Yeah, maybe the principle goes from being a KISS principle to a KISSed principle. Keep it simple, silly, exceptionally. Oh, dang, I couldn't get the dollars. Somewhere D comes in the dollars part. But the point is, kind of driving to David's point, which is the reason why we want simplicity is simplicity when it comes from an R&D perspective, an engineering perspective, and then most importantly, a manufacturing perspective, phenomenally drives the cost.
And the licensing perspective too, right, Sascha?
What's that?
And the licensing perspective too, right?
That's right, with the FAA, right, as we're finding out right now. Yeah, so it greatly benefits us, and it is really difficult not to be tempted away, by the dark side of the force, or maybe it's the good side of the force, I don't know, being tempted away So, but that's what it comes down to is we want to provide a capability to replace solid rocket motors, and in some cases liquid rocket motors that that is economic changing, that is changes the rules. We also know that the marketplace is yet to see this. Like they've yet to feel it, understand it. I'm looking forward to the moment when everybody says, yes, of course, hybrid rockets. That's why you would do that. This is a great place for hybrids as to maybe. So instead of sort of the copy mode of the SpaceX's, the Blue Origin of the world, or the solid rocket motor companies of the world, we will see in the marketplace a new type of propulsion that makes absolute economic sense in certain applications.
Yeah.
Because of that simplicity.
And I'm sorry, go ahead, David, if you want to follow on comment of that.
Yeah, I think the relevant follow-on is that there are multiple companies looking at the use of hybrid rockets for small launch like us. The applications that people are looking at with hybrid rockets are not massive payloads and not tactical applications for missiles in offensive settings to like replace, the niches for things that are working like a HIMARS and the niches for things like a Starship.
Yeah.
But there are places where hybrids are being sought out by companies all over the world that are looking at applications like testing, like suborbital launch, and like maybe even some tactical applications that don't have the same space constraints, the same like volume constraints. And so there are multiple points of evidence pointing towards the efficacy of this system. We're doing a few other things uniquely, I think, compared to those other companies, and trying to keep things exceptionally simple. And our fuel really helps with that. But there's evidence that hybrids are the right solution for this use case for small launch.
So you mentioned fuel, and BioShift is often associated with bio-derived rocket fuel. Sascha, you've even eaten it on CNN. What does that actually mean in practical terms, and what can you share?
Yeah, so I mean, what that means, there's multiple practical terms, but one thing is availability, ease of availability. Another is the logistics. So think about now. I want to clarify too, like when people think of biofuel, you might think of like biodiesel. Biodiesel, by the way, often has, I think it's methanol they put in there. You don't want to touch that stuff. You really don't. Just like you don't really want to touch gasoline on an extended period of time. It can be bad for you. So sometimes there's equivalency between bio-derived and like it's going to be non-toxic, but it isn't. You can't always have something that's you can have things that are bio-derived and not toxic or dangerous. We happen to have something that's bio-derived, not dangerous, easily accessible. And so what that means is, once again, like when we're doing our recipe for our fuel, when we're blending it, when we're manufacturing our fuel grains, everything is far simpler. You think about solid rocket motors. I mentioned our previous podcast, the explosive nature of it, the danger. What I didn't mention is that on occasion these manufacturing plants blow up because you're inherently mixing up something that has a TNT potential.
Yeah.
And we just don't have those issues. So we don't have to have like anti-static gear while handling our fuel. We don't need to get a special environmental permit to store our fuel on site. We don't need cryogenics. So you compare it to liquid fuel rockets, whether it's liquid methanol, methane, or the oxidizer or liquid oxygen. We don't have to deal with cryogenics, which require a lot of energy, are very dangerous, and of course, can be very hazardous to people if they get in contact with it, let alone the explosive nature. So all that, once again, like it just drives down the cost. So the biofuel is an exceptional important part of our recipe, no pun intended, for was the success of our system. But the fact that it is just biofuel itself is the critical part. It's choosing something that is technically makes life easier, and also technically produces a lot of energy really fast. So our fuel is able to give up give up its energy exceptionally fast when you compare it to traditional hybrid rocket fuels. And it's more energy dense than liquid rocket fuel. And all those things kind of mean that we as a company use a completely different supply chain than the very fragile supply chains that you see in place today with the solid rocket motor companies, let alone if you're having to keep a constant supply of liquid oxygen on hand. We just don't have those supply chain constraints. And from a national security standpoint, that's also a game changer.
David, what was it like for you to kind of realize or see that come together and then it launched something?
Yeah, I think that working on that biofuel, especially in the early days, and seeing what some of the engineers were doing in terms of manufacturing approaches, it almost didn't feel like you were dealing with the rocket fuel. You expect it to be volatile. You know, anyone that's played with like toy SD's rockets, that fuel is basically gunpowder packed in a certain shape that makes it burn in one direction, and it's as volatile as that. Even as a toy, you got to be careful how you treat it. When you start to scale up to the sizes of our 4-inch and our 6-inch motor, if that was a solid fuel, that would have been exceptionally dangerous to deal with, and we wouldn't have been able to do things as quickly as we did. So I think experiencing working on that solid fuel in the early days and the manufacturing methods that we were using, we tried all sorts of different things that if you had tried that litany of things as brazenly as we were capable of doing because the fuel's safe on a solid motor, someone would have gotten hurt. And that luckily for us, deliberately, not luckily, we managed to make that, rapid fuel formulation changes, rapid fuel manufacturing process changes. So that's what it was like for me. Just understanding that we were dealing with something that we could iterate on quickly. Didn't feel like normal rockets. Yeah.
That's cool. All right, well, let's take a step back for just a second. And, David, I want to hear, more about your background and what led you, to meet Sascha, to get involved in the skunk works of the other company, and then ultimately be part of the growth of bluShift.
Yeah. Sascha broke down the experience from his point of view. I think for me, at the time I was working, I had my own small business called Maccabee Tech, and I was always networking, always trying to find new customers that were working on. Usually I was looking for someone that wanted to work on the interesting stuff, automotive, aircraft, rockets. That was always my favorite kinds of projects. And in Boston, it's not a huge market. We were based in Cambridge at the time. And yeah, I saw Sascha's sort of advertisement for a meetup for space enthusiasts, and I thought this would be a great place to find potential customers that have the kinds of products that I want to work on. I was so confused when I walked in and we sat down, and he was like, "All right, here's the big idea." And at first, I think I was looking at the room, and I was struggling to be like, I'm not sure where the networking opportunity is here, but what this guy's talking about is something I want to do. And everyone was working basically sweat equity at the time. Anyone that decided to put in hours, we weren't getting any pay for it. But right away, the idea seemed reasonable. I started showing up to all the meetings. I got introduced to the little machine shop, and we started making parts. And people came and went, and there were some really bright people along the way. But some of those people are still here. And Luke was one of the ones that I met early days. Brooke as well, one of our first full-time hire. They were people that I think also invigorated me and made it become more and more interesting to keep working on it. Like I said, friends and coworkers, but mentors as well, in the sense that everyone had a skill set that they brought to the table. And Sascha's enthusiasm, Sascha's ability to dig into a problem and find a reason why that problem is an opportunity over and over and over. I think we're running into a roadblock, and Sascha, for a second shows that same sense. Oh yeah, that's a challenge. But what if we do this? And it's always that way. There's nothing's ever a showstopper for Sascha. And I think that's also, I think that gets everyone on the team a lot more optimistic about what 6 people, 10 people can do. I mean, we've got a 36-foot tall test stand out there that's about to grow to 50 feet, 60 feet when we go to test vertically pretty soon.
Yeah.
And that started with a couple concrete blocks stacked up and a 4-inch diameter motor about a mile away with a couple people working just for equity back in the day. So it started very humbly and not in the way that I intended it to. And it's evolved into something I couldn't have imagined, but I'm extremely grateful for.
That's so awesome. There's always a gap between the theory of what you want to get accomplished and then ultimately the reality. And you continue to push those boundaries. You each do in different ways, but and you do that through tests. And one of the things that comes out of there are the results to be able to make iterations and improvements. How do you go about you deciding what those tests are going to be and making adjustments to whether it be the fuel grain or the what you're trying to solve for and realizing when the trajectory is going to change?
Yeah, we've got a set of levers that we can pull in terms of how we're modifying the design, and some of them are low-hanging fruit that have a big impact, and some of them are nuanced things that require a lot of analysis and a lot of testing to figure out if they're going to do what we expect them to do. But I'd say every test we go through, we see how we're doing in comparison to our benchmarks. And we've got a set of simulation tools that tells us how things will fly given a set of engine test results. How quickly did it burn through the fuel? What sort of thrust did it produce? Those kinds of metrics. And it's a really key thing in rocket propulsion. I'm sure anyone that's listening to this that's familiar with rocket propulsion will have heard of the rocket equation. But your start mass, your end mass, and your impulse are the things that determine how fast you can go. It's more complicated than that, but at a basic level, those parameters are a lot of what we're extracting from our engine tests. You also want things to be smooth and safe and stable. So we're extrapolating all that data out of tests and adjusting our levers. How do we inject our oxidizer? How do we modify our fuel geometry? Where do we add thermal protection systems to make sure that things are more resilient? And yeah, we adjust these levers. What can we add to encourage mixing of the fuel and the oxidizer? What can we do to encourage more fuel regression, more of that, what Sascha was saying, that release of energy, or how do we contain it in certain areas? These are the levers that we try to adjust in every test. I'd say there are things that we expect to do 2 tests from now, and sometimes that repeats. And sometimes 2 tests from now is completely different than what we expected because we discover the unknown unknowns as we test. So yeah, I'd say that's the key, like big key part of the process and part of the reason for testing. We want to move towards that vertical test as soon as possible, by the way, because some of the time what we're discovering when we test, if the configuration isn't exactly like flight, it's things that maybe we're solving problems that we won't need to solve on our flight vehicle because we're testing in a configuration that isn't exactly like the flight vehicle. So that's another thing that you learn. It's the method of testing that gets you closer to the end result you're going after. It's not an academic approach. It is sometimes, but the objective is a practical one. Get the rocket to this altitude with a high sense of reliability. So that's what we're always hunting after in these tests.
That's cool. Sascha, without getting into anything, too proprietary, what gives you the actual confidence that this approach will scale and you'll be able to, hit the objectives that you've set, return on investment from investors, or what gives you that confidence?
At the core of it, we've done it once already. We've done it at the small scale when we took Stardust from being a test engine, like a smaller version of what you see behind David right now, to all the way to launch. So we know what that looks like. We've had the whole experience, albeit at a smaller scale, what it takes to take an engine, make it flyable, make it reliable, make it work. And of course, we've learned things then. We've also learned a lot with this bigger engine. But I think what's also important to take into account is that, well, yes, there aren't a lot of commercial hybrid rocket companies today, and most of them are international. There have been a lot of hybrid rocket studies and research. There's a company called, I think it's called AMROC, which one of our advisors was involved with. I guess technically 2. And they built hybrid rocket engines, albeit with a different fuel, and different oxidizer. That was, I think, wasn't it, David, like on the order of quarter of a million pounds of thrust, I think. So just about 10 times bigger than our engine. So we know that this technology is capable of scaling. And we haven't touched the top of that part yet. At least we won't be breaking a record in terms of scaling it. But we've seen such improvements in the last series of tests. Even our very last test, that performance that was provided already demonstrated to us that if that engine had launched, if we packed it up into a vertical configuration and launched it, we would have been able to take paying customer payloads to space. And so we know we're on the cusp of that. And so what we're doing right now is we're on the edge of, let's refine that, let's make it even a little better, and let's optimize it further yet for our hypersonics customer to get their test engine up to speed. So, I mean, it basically comes down to the evidence of what we've done and where we are, and having done it once already at a smaller scale, and seeing what others have done in the decades behind us, and knowing that we are literally learning from some of their mistakes, because some of them are actually giving us that advice so that we don't make those mistakes. I think it really sets a very strong path forward for us.
That's awesome. All right. So for people that are outside of the industry, what's most commonly misunderstood either about the idea of the hybrid rocket engine or the rocket propulsion in general that you guys think that it's really important to clarify? We're early on in this podcast, so we need to set the record straight early.
David, I think you should take this question because I think you can kind of get into the technical part of it. The first thing my mind goes to is safety. Like you think of rocket engines, and certainly you're still trying to deal with something that's under pressure, but the safety is significantly different in a good way than either liquid rocket engines or solid ones. But Dave, why don't you take this question because I think you could really kind of go into the depths of this one.
Yeah, I'm happy to. I think you're right about safety. That's one of the big ones. Is that it's as I mentioned, it's easier to make, it's easier to store, it's easier to launch and operate. It's a funny misconception that you don't hear very often, but you hear it sometimes. Hybrid doesn't mean it's using two different kinds of propulsion systems, like in a car, which is a funny misconception that I've heard from a few people. All it means is that you're using two different phases of propellant. So you're using a solid phase and a liquid phase. It's a silly misconception, but it comes up very often. And I think that the other one would be, what Sascha mentioned. There's a 250,000 pound thrust motor out there, and people ask, "Oh, are you gonna go after SpaceX?" And like I said, the liquid system is great for heavyweight orbital launch. Not saying that a hybrid couldn't be used for that, but I think one of the misconceptions is that the only kind of launch is heavyweight orbital launch, and people maybe aren't as aware of because it's not as glitzy and glamorous. The massive market for hypersonic testing, for suborbital testing, including for systems that are going to be used in long-term orbital applications. But maybe people want to deploy a piece of hardware into microgravity for 5 minutes and then recover it and assess it on short notice, within minutes. And you can't do that with the launch of something to the ISS. You can't do it with the launch of something going into orbit for 6 months. But you can do it on suborbital trajectories. And to have a system that's safe to operate and exceptionally capable at delivering that specific kind of performance, that's a misconception that I think, not so much a misconception, but something people aren't aware of about where hybrids really can fit in to the propulsion world and where their benefit is from a commercial standpoint.
The other thing that I think at the core of it is, well, yes, doing anything we get to build things costs more money than like software. I think the other misconception is how much, how the capex, the material difference, the what it takes to build an engine that's a hybrid engine, especially using the propellants we use. I think that's highly misunderstood from venture capital people to the general public. And in some ways, that's the same thing when it comes to sort of understanding how rocket engines work. So there's just this belief that it has to be exorbitantly expensive. And it doesn't take tens and tens of millions of dollars to stand up all types of rocket companies, but it does take tens to hundreds of millions of dollars to stand up some of the most famous rocket companies, if not billions.
Yeah.
I mean,
Well,
you think of like the SpaceX Raptor engine. I mean, that I heard from one person in the government, it took $1 billion of Department of Defense research to help SpaceX develop that engine. I don't know if that's true, but that's what I heard. That's a handy subsidy. Yeah. And here we are doing something phenomenally different for phenomenally less.
Yeah. That's really interesting. All right, so I'll get you guys out of here on this because I think there are fortunately with the topics that we've covered so far, we can unpack a lot and then turn them into future episodes. So definitely looking forward to some of that and going deeper into into some more of these details and what is important here. Thinking about what's ahead. What are some of the next maybe technical milestones that matter most to bluShift that you have on the radar that you can talk about?
Sasha, I'm happy to take this one on. Yeah.
Yeah, take that one.
There's a license application for launching commercially that in the short term I'd say is a technical hurdle that is the most critical for us because it drives so much of the updates and the potential design, and that basically is hinging on the ability to make the rocket fly along a trajectory that's extremely predictable despite it not having a guidance system at the moment. We want to be able to launch it and know with a good degree of accuracy where it's going to land so that we can make sure that when we're doing our initial test flights that validate how the propulsion system works in flight, that it's safe for the general public. And the FAA has been really helpful in that process. Our advisors have been really helpful in that process, and our engineers are doing an incredible job of building simulation tools and implementing whatever those simulation tools are telling us about our design into the vehicle. And that's informing a lot of what we're doing in testing. More interestingly for me down the line is what's going to happen once we get through this first flight. There's a lot to do to get through this first flight, but I think the steps that come immediately after that, which is scaling for production and upgrading the vehicle to work in ways that will apply to more customer demand. So, for example, building in an attitude control system that at the moment we're planning on using spin to stabilize the rocket because it's unguided. So we're going to rotate it on the way up. That adds stability and reduces how far away it's going to fall from our expected landing sites, to having a attitude control system that will guide the vehicle in flight to send it on trajectories that are maybe a little bit more deliberate and less ballistic. So some of these steps that we're planning on taking for the future iterations of Starless Rogue are what excite me. The technical hurdles that we have right now to get to flight, there's still a lot of them, but it does feel like the key now is to build and test and basically materialize what we've already determined at this point to be the right path to our first launch. So the launch itself will be a major technical hurdle to overcome, but maybe the development that comes after that is where we get to really show the world what this system's capable of.
David, that's incredible. For you, Sascha, are there any other milestones on the technical side that you're looking forward to, or that you want to follow on to, what David shared?
I mean, the one I'm really excited about was the one that David, I think, was referring to before, which is getting that engine vertical on that test stand behind him. Getting that up to a few feet and seeing the full stack fire. That is going to be, and I'm going to use this word, I think, in an appropriate fashion, an awesome moment. But I think the other part that's a little less technical, but actually it's a whole lot less technical, but it's really important for our company, is when we sell an engine to our hypersonic customer, that's going to be a really pivotal point for our company, being post-commercialization. I mean, truly, we're going to be post-commercial before then because they're paying us for some of the testing that we're doing. But to actually sell a unit, sell a product, which is kind of where my years of experience have been in my previous companies, and having that transaction is a really important, pivotal moment for us. And I can't wait for that day. The day I get to send the invoice, the day we get to get payment, and the day I can say we are very much post-commercial. So exciting.
Okay, cool. Well, guys, I really appreciate you joining me today to talk a little bit more about the technology and the reason why, what, not just what you built, but why you've done it. I think, that's certainly inspirational to hear, and it's so neat to know that that is happening in Maine. So, really appreciate your insights today and joining me.
Thank you, Justin. Yeah, it's been
Thank you.
awesome.
Yeah, it was good fun.
Well, I can't wait to do this again. As I mentioned before, David, I think we'll have to have you as a regular contributor to go deeper and wider into some of these things, because your insights
Love to do that.
and where you're at with stuff is really awesome.
I think we should also sneak a couple of live commentaries during an engine test, which is a really hard time to bug David because he's really intensely focused on making sure everything goes okay. But that could be, or at least get his impression after in test.
We might have to put a hot mic on him or something.
Yeah, that's true. Yeah, put a hot mic. Yeah.
And
No
then
pun intended.
Sounds good.
edit out those swears and stuff. So
Yeah, that'll be a lot of beeping.
They flow prolifically when I'm
Yeah.
not paying attention to it. So yeah.
All right, well, good deal. Well, on behalf of my guest today is Sascha Deri, CEO, and David Hayrikyan, the CTO of bluShift Aerospace. You've been listening to the Throttle Up podcast. Until next time.